私、理科研究所計算科研究センターの野中と申します。本日はこの OpenViSUS のチュートリアルにご参加どうもありがとうございます。本日は、この会場での参加以外にも WebX 上での参加っていうのもございまして、今ちょっとこちらっていうのは今回が2回目の試みでちょっとまだ不慣れなところもあってちょっと見苦しい場面を見せてしまって申し訳ございません。でまずはじめにちょっとそのお知らせとお願いがあるんですけれども、まず一つこの、皆さん、入り口でいただいたかもしれませんけれども、今回がこの2回目の WebX のチュートリアルでありまして、で次回今度スパックと呼ばれるツールのチュートリアルもございますので、こちらも WebX 配信予定ですので、こちらのご興味がある方はぜひまた申し込みをご検討よろしくお願いいたします。またそのフォームに、アンケートの、リンクがございまして、こちらのアンケートにもぜひご協力をお願いしたいと思います。でこの WebX なんですけれども、通信が不安定になって切れた場合はもう一度同じ URL にご接続の再接続を試みてください。でまたこの、遠隔からの方々になんですけど、通信の配信というのは一方通行になってまして、もし質問などはこのチャット画面というのがございまして、そこから質問などをお願いいたします。また後日メールベースでこちらでも直接この講師やってくださっている方々にも送っていただいてももちろん構いません。Well, thank you very much for attending this OpenViSUS tutorial. And we are very happy to have Professor Valerio Pascucci and also his team that is in Utah to provide this tutorial that is for large data visualization based on streaming. So I won't take much time. And if you have some questions from who is attending via WebEx, we have this chat window, and please send the message or the text message, and you can select to send for the all audience, for only for the presenter, or also for the organizer. So please.
Okay. Should I use this microphone?
Yes.
Okay.
And
okay. So yeah, thank you everybody for attending this tutorial. So the goal here is we'll do a few slides or presentation of the technology, but we'll really focus on getting people to try the software on their laptops. And so there will be some steps of programming in Python, installing a server for the data, and things like that, and hopefully demonstrate that it's kind of very simple and reliable to work with. So we have connected from Utah, Steve Petruzza and Aniket Venkat, the first two names here in the list. And so they will help running some of the examples, and also they will be in touch later if you guys have additional questions. You can also get in touch with us via email. So one thing that I was hoping to do, if people are comfortable with, so the topic that we're going to touch will range a little bit about using an I/O library for scientific simulations, set up a server to watch a simulation running in real time, but also showing how to distribute data sets from imaging lab, microscope, and things like that. And so if people are willing, we would like to kind of maybe make a round and people introduce themselves very quickly. The group is not huge, so we can do it quickly. And that will help, and most of all say, what is the main interest that bring you here to the tutorial. And so if anybody online wants to just indicate, and again, the main thing that I was hoping to tease out So we have the technology is useful often for imaging devices and simulations because at the end they all deal with large data sets. So if people have preference, we might emphasize one aspect or the other. So this is the OpenViSUS framework, and we have been developing this for over 10 years now. And so it used to be a few years ago mostly a research project, and now actually has become both something that there is a company that is developing on a commercial level, as well, obviously, we continue to do the research on the university side. The infrastructure is all open source, so the company side can provide support for installation, software engineering, extensions, but at the end of the day, the software, it does not require any license. People can just take it and use it directly. We have a number of projects with the Department of Energy that are using this in the United States, and so we have been working with other large supercomputers in addition to the collaboration here in Riken with the various projects, Oak Ridge National Lab, Argonne National Lab, Berkeley, and so on. And I don't know if anybody followed the presentation on Monday, so there will be some overlap and repetition, but I think for those that didn't, it's important to make some of those points. So the technology has been developed dealing with lots of both simulation data and data from experiments, microscopes, satellite data, array of images and cameras, and so on. And basically, we can deal with very, very large arrays, rectilinear grids, and on the simulation side, also AMR data. We are evolving also towards incorporating point sets, kind of particle data in simulations, but that's still at the experimental level, is not quite ready yet. So we'll focus on kind of big arrays, Cartesian grids, and things like that. And that's where you will see easily the simulation between imaging and simulations. So the one aspect that we are particularly been focusing on in the last few years is how to make it scalable and easy to use on many different devices. So we have, we'll show later how we have focused on container technology to make it easy to install and run. We have embraced heavily Python as an interpreted language on top of our C++ core. On that front, actually, we would love to have feedback if people are not using Python or Jupyter, but they're using maybe R or MATLAB. That's something we have not done, but we are potentially considering depending on how much need there is among the users. The aspects of scaling is kind of represented in this image. We can, so we have an I/O library that can be used to convert data or acquire data directly, save it on simulations. That's one of the first things we'll demonstrate. And then we have a server can easily distribute data. And then we have a couple of solutions for clients, one very light on web-based and one heavier that includes a full Python processing layer that can be used to process data. We have deployed, everything runs on small devices, so laptops. The server actually runs entirely even on a hard disk. So we have things like Synology hard drive, where we can install the entire pipeline without need of an additional computer behind it. And then we have demonstrated use in a number of different cases. The library is structured in a number of components that are fairly independent, and we're making even more and more independent. So if people need only loading and saving and loading data, there is just a small piece of the library that needs to be incorporated, and the rest is not needed. Then there is a component that has a scene graph and a user interface, and that will be when you people want to build a full solution. And then with a various combination of those aspects, we have been building over the year a number of use cases. For example, we have some for running on power roll display, so we have kind of a distributed set of clients that connect to the server. We have been using that for stitching large number of images, and we have a solution that we're doing now for agricultural application. I'll show at the end a little video of that. We have been using this for climate data from NASA. They have a very large data set, around over a petabyte of data, and they visualize it in streaming. But all is also wrapped into Python, so you literally can just use it in a command line interface only purely for processing data and doing analysis, even if you use something else for visualization. Our viewer is kind of well known to load on a laptop massive data sets that other solutions like ParaView, Visit cannot deal with, simply because they load everything in memory. So one of the first things I'll try, actually, there is a data set that's about 7 terabytes, 6.5, and I'll show streaming, visualize it on my laptop. Obviously, I don't have a hard disk that big, but certainly with a solution like ParaView or Visit, you couldn't load it unless you have a cluster or something really much bigger than that. But at the same time, we're not replacing those tools. They have lots of functionality, so what we really advocate is that people can visualize, explore those large data sets. Very often you might narrow down on a sub-block that is of interest. From that one can open another tool very easily, something that normally is very hard to do on this massive data sets. So to go immediately to something fairly concrete, so we will have Steve Petruzza make a first demo of how to run a small simulation using PIDX. So PIDX is a specialized version of our library for parallel computing. Has the same format as the regular library, OpenViSUS, but given the special needs of doing things in parallel and so on, we separate that from the core VISUS library, but they share again the same file format. And I'll have now Steve take over the screen. Steve,
yeah.
Are you on?
So the Georgie has also in Riken the checkpoint restart.
Should we do it?
So if he's connected and can share the screen, he could.
Georgie, you want to do the demo of PIDX, or should Steve do it? Either way is fine.
I don't know what is So in the slide you can see there is a URL to the repo of PIDX. There you can find under examples some examples of the APIs for reading and writing into this multi-resolution data format.